Hi guys. The purpose of this video is to go over some basic circle vocabulary, specifically from the Unit 10 classwork packet. If you're not quite sure where to find that, as always, please look under Modules, Unit 10, and it should be called Unit 10 classwork packet. Alright, so we're going to be starting off today on page 3 and just going over some basic terms that you guys need to know before we can actually start talking about how to approach circle problems. The first is, what is a circle? Now, we actually did this before we unexpectedly closed school, but a circle, if you'd like to write down the definition, is a set of points that is equidistant from a fixed point called the center that lie in a plane. So let's try that one more time. So a circle is a set of points that are a fixed distance away from the center that lie in a plane. Now it's very important, that last part, because if you don't specify they lie in a plane, instead of a circle, you will have created a 3D figure known as you guessed it, a sphere. All right? And this should be our picture for a circle. Now in pre-algebra, many of you guys know, or learned rather, that what a radius was. It's simply a segment that connects the center and the circle. A segment that connects the center and the circle. And we would call that R. Okay? Now a chord, by contrast, that's something we may not have heard about. All right? A chord is actually a segment, which I'm going to draw right here. And notice where it is. It has each of its endpoints on the circle. So a chord is I'll label it right here. Chord, C-H-O-R-D, is just a line segment that has both endpoints on the circle itself. Now, there's a very special chord known as the diameter, and the diameter is actually the longest chord of all. All right? Now, we know the traditional definition of a diameter. It's just a straight line, or you might want to say a line segment, that passes through the center of a circle. All right? So you can think of a diameter as the longest chord, or you can just think of it as twice the radius, whatever works best for you. All right? Now, a secant, this one's a little bit difficult. All right? A secant is kind of like a chord, but the only difference is, instead of stopping at the circle, a secant would do this, all right? So a secant actually passes through it twice. It doesn't just stop when it hits the circle, it actually passes through it twice. A tangent, instead of passing through a circle twice, it's actually only going to touch it once. And so a tangent line, sorry about the bad drawing here, but we do the best we can, right? A tangent line just touches the circle once, and that special point where it touches is known as the point of tangency, okay? For those of you guys who one day will take something like AP Calculus or, multivariable or whatnot, you may hear something called derivatives. When you start learning about derivatives and instantaneous rates of change, you may actually need to refer back to this as the first time you ever heard about tangent lines and why were they ever going to be important. But not to scare you, all right? So as long as you guys know that a tangent is just a line that touches the circle once, we should be good, okay? All right, let's press on, shall we? Okay, so now I'm going to erase this diagram, just because I kind of don't have much space here. I really miss my triple new whiteboards. So sad. Anyway, so let's talk now about a central angle. A central angle, as you might have guessed, is an angle, but its vertex is right here. In other words, the sharp corner, all right, of the angle is just right here at the center. So once again, what's a central angle? A central angle is just an angle inside a circle whose vertex is at the center. Once again, a central angle is simply an angle inside a circle whose vertex is at the center. Now, by contrast, I'm going to draw another picture over here. An inscribed angle is a little bit different, okay? An inscribed angle kind of looks like a V, right? Instead of the vertex being at the center, where's the vertex? Well, it's on the circle itself. Later on in this unit, we're going to have a little bit more to say about the relationship between central angles and inscribed angles, but again, I don't want to terrify anybody, so that'll be coming relatively soon, okay? Okay, Arcs, we've talked about this a lot, right? Those of you guys who have me for advanced topics or for some periods of geometry, we've talked a lot about arcs with constructions. What we said then is that an arc is just a piece of a circle, and that's exactly right. It's a portion of a circle, or you might want to say it's a portion of the outside of a circle. So for example, this, I kind of like mutilating a marker here, but this piece right here along the edge, it's a fraction of the circumference. It's a piece of the outside, all right? And later on, we'll actually learn how to calculate how long that is. Now the next two, minor arc and major arc just means it's small. And in this case, it just means it's smaller than 1/80. So what should we write down? A minor arc is a piece of a circle that's less than 180 degrees. By contrast, a major arc would be, you guessed it, greater than 180 degrees. And last but not least, a semicircle. Well, semi, you know, means half, so a semicircle is just a half a circle, and I wonder how many degrees that could be. 180. Okay? Now for the formulas at the bottom, here's what I want you guys to fill in. And I'm actually going to ask you to write one more thing apart from what's written there. We're going to talk about these a lot more later and how you actually get them and work with them, but for right now, these will suffice. Area of a circle is defined as pi r squared. You guys learned that first in pre-algebra, or possibly even 7th grade for some of you if you had advanced, all right? And now we're going to be applying that to find area of sectors. But for right now, this is a must-know. You absolutely positively must memorize the area formula for a circle. Circumference, all right, is a little bit different. You can either say 2 pi r, or you can say pi d, so pi times the diameter. They're equivalent formulas. It doesn't matter which one you use. Just be careful based on the problem that you give you. Sometimes they give you a radius, sometimes they give you a diameter, and whichever one they give you will determine which one you can actually end up using, okay? Now, for arc length, I'm going to write something really funky and complicated up here. Don't worry about it too much. We're going to talk about what that means later, all right? But for those of you guys who can already see this, the arc length is simply the fraction of a circle, so the central angle divided by 360 times the circumference. So it's just the piece of the circumference. I want you to add one more thing, and this is going to be called area of a sector. If we have time, we may come back to this. This is what I like to call the pizza problem, but it's pretty much the same thing as arc length. The only difference is, instead of multiplying it by the circumference, you multiply it by the area, because an area of a sector is simply a fraction of the area of a circle. All right, so in sum, what have we just taken a look at? We have just done the essential vocabulary for a circle. Now, in our next video, what we're going to take a look at is how to use area and circumference formulas specifically to find area, circumference of circles, to possibly back solve for a variable when need be, and eventually to apply it to arc length and area of a sector. Now, I know that was kind of fast, which is why I'm recording this, so if you're still confused, I would suggest playing it again, and then during office hours, if you guys have any other questions on that, please by all means let me know. Okay? Thanks for watching. Bye-bye.